Good afternoon, and I welcome you students. What we are studying the chapter of light, reflection and refraction. Last time I have told you what will be also asked in the board paper, coming board paper. This is in our course, light is in our course in the coming board paper. But we have told you plane mirror, concave mirror, convex mirror. We have also shown you how the image is formed by the concave mirror and convex mirrors. And we have given you the uses of the concave and convex mirror also in our previous lectures, which are already available in the YouTube. Tell me, did we did all this? Yes or no? Be with me. Be with me. Okay?
Yes,
participate with me because we are preparing for the question answer sessions also for the coming exams, and you have to score full marks in that. Now, you have seen that the concave mirror is a mirror which is used for what purpose? Can you give me one important use of concave mirror? One important use of concave mirror, tell me. What is the most important use of concave mirror? Where it is used? Concave mirrors are used in for what purpose, students? Dentists are using which mirror? Tell me. Which mirror is used by the dentist? What is your answer, students?
so concave mirror.
Why? What is the position of the object when the dentist uses the concave mirror? What is the position of the object? Where it is placed? Between, we have given you as the position of the object changes, the different images are formed by the concave mirror. So when it is between pole and focus, what happens? What type of image is formed? What type of image is formed? Important. When we say that, when we discussed the uses of concave mirror, students, we told you when the concave mirror is between, when the object is between P and F, what happens? It forms a virtual, erect and magnified image. It is also used as a shaving mirror. And the most important use of convex mirror was, what was the use of convex mirror? So it is a, what we told you, student? Here. What was the main use of? What was the main use of the concave mirror? You said it is used by the dentist. Also, we told you it is a shaving mirror. And when the object is between P and F, pole and focus, it forms virtual, erect, and what type of image? Enlarged. Is it correct? And then we discuss the uses of convex mirrors. Can you tell me one important use of convex mirror? Where it is used, you are using it. The most important use of convex mirror that will be asked in the paper repeatedly in the MCQ form question also. We will show you the questions. Tell me what uses. What is the main use of convex mirror? Is it used in vehicles? Yes or no? Your vehicles are using what type of mirror? Vehicles. What type of mirror is used? Rear view mirror. So we are aware of it. What are the uses of this? Here is a question number 1, student. Question 1, top question is coming on what we have learned till now. Before we go further, first question, define the principal focus of a concave mirror. You have 1 minute to answer the question. What is the answer of this? Define the principal focus of a concave mirror. What is the principal focus of a concave mirror? What is our answer? You have seen this is our concave mirror. Concave mirror, how you draw it, student? This is your principal axis. This is a principal axis. What is the focus of a concave mirror? This is our pole. What happens when the rays which are parallel to the principal axis, where will they converge? This is a ray parallel to the principal axis. This is my principal axis, students. So the ray which is parallel to the principal axis, where they converge, they will converge at a point which we call as a focus. Tell me yes or no. Where they converge? This point. So the rays of light which are parallel to the principal axis, they will meet at a point which we call as the focus. So can we make the definition now? You should not mug the things. You should try to learn it so that you can write the correct answers. So we can say the point on principal axis, the point on principal axis of a concave mirror, okay, where what happens? The rays of light parallel to the principal axis. This is principal axis. These are the rays of light parallel, where rays of light parallel to principal axis. What happens to them? They will meet after reflection. They meet, or I am saying converge. They are meeting or converging at this point. They meet or converge. Okay? Meet or converge after reflection. Okay? This is called the principal focus. Is it clear? And this distance is called focal length. F. What is F? We have also defined what is a focal length, student. F is equal to this distance, PF. P is the pole, F is the focus. This distance is called the focal length of a concave mirror. Is it correct? Tell me yes or no fast. Can I proceed further?
Yes, sir.
Okay, keep your notes ready. Question number 2 is coming top. Question number 2, student. The radius of curvature of a spherical mirror is 20 centimeter. What is its focal length? Okay, you have 1 minute to answer the question. R is 20 centimeter. What is the radius of curvature? What is the radius of curvature of a spherical mirror, student? We have told you two mirrors, convex and convex. What was the relationship? What is the relationship between radius of curvature and focal length? R is equal to 2F. And then what is F then? R by 2. So what will be the answer? 20 centimeter by 2. What will you get, student? 10 centimeters. Very simple question. So the focal length of a spherical mirror will be 10 centimeters. No problem here. All right. Next question, top question number 3. Name a mirror that can give erect and enlarged image of the object. What is your answer, students? What is the answer? Which mirror gives erect and enlarged image of the object? What is the answer for this? We have shown you the image formation by concave mirror and the convex mirror in our previous lectures. You have the notes also with you. You have the YouTube lectures also with you. Tell me which mirror will form erect and enlarged image of the object. Convex or concave? We have just shown you again. This is concave.
Concave mirror.
Concave mirror is the correct answer. And what is the position of the object? Where the object is placed when it will form erect and enlarged image? We have shown you ray diagrams. Position of object is between P and F. Okay? Between P and F of a concave mirror. The ray diagram is available with you. You have drawn it last time. Such questions will be asked in the multiple choice question. They will give you 4 choices. They'll ask you that. Another top question number 4, student, is very important. Why do we prefer convex mirror as a rear? Again and again, I think convex mirror are used as rear view mirrors in vehicles. In your car, on the right side, on the left side, which mirror is that? Convex mirror. Why you will use that? What is the reason? What is the reason? What do you think? What is your answer, student? Because it always forms. It always forms. What it always forms? Tell me. Convex mirror always forms. What type of image we have shown for the convex mirror? For concave mirror, I showed you 6 cases when the object is moved towards the mirror. But in this case, we have shown you only 2 cases. One, when object is at infinity, then you got a point-sized image, appears to form a point-sized image at the focus. And another we showed, you put any object, what type of image is formed? Was it enlarged, small, diminished, or what type of image was it? Virtual, erect, or what type of image was that? What was the answer? What type of images were formed? Always forms what? Virtual, erect, diminished, and full size image of even distant objects. Is it clear? Yes or no? You see the traffic behind you in the car, which is coming. What you see? You see full image of that. The traffic is far away. You can see that. So it gives virtual, erect, diminished, full size image of even distant objects. 1, 2, 3. These are the important points. Full size image. You can get full size image by using convex mirrors. What is the reason? Because its aperture is large. The convex mirror has a larger aperture. You will see that these mirrors are finding great use. Various traffics or various diverted roads. They will give a complete view of the back, rear view of the traffic which is coming. Is it clear? This is an important point. This question is important, has been asked many times. All right, student, let us move further and see. Very important thing is coming, sign convention for reflection by spherical mirrors. Why we need sign convention? Why do we need sign convention, students? You see that in NCERT book you will find, while dealing with reflection of light by spherical mirror, we shall follow a set of sign conventions called new Cartesian sign convention. This sign convention is important in solving questions where what is the position of the object, what will be the position of the image, and there is a mirror formula which will be used to find if I have an object at 5 centimeters in front of a mirror, then what type of image will be formed, where it will be formed. So for that solving questions, it will be necessary to use a sign convention. This sign convention is accepted internationally, and this is what we are talking, sign convention for reflection by spherical mirrors. This is called new Cartesian sign convention. In this convention, pole of the mirror is taken as the origin. Where is the pole? Important point. Pole is taken as the origin. Pole is, note down everything. Pole is taken as origin. Where is the pole? Tell me. This is the pole. Can you see the pole? This is the origin. We will take this as an origin. Okay? Pole. Next, this is my figure 10.9, which is taken from NCERT book. The principal axis of the mirror is taken as x-axis. This axis, which is the principal axis, I am taking as x-axis. Principal axis, we have already defined what is a principal axis. We have shown you an imaginary line passing through the pole, which is normal to the pole. That is the principal axis. Now this principal axis is taken as x-axis. In maths, you know, You use x-axis, yes or no? Tell me, maths. This is my original. Okay, this is my origin, and here is my. If this is my 0 point, then this is my x-axis. So you have plus x-axis and negative x-axis. Clear? Plus sign on this side. What is the sign? +1, +2, +3. If I do the maths here, -1, -2, -3. Are you aware? Yes or no? Tell me. What will be this? 1, 2. This will be +1, +2. And if I put 1 and 2 here, what will be these? Minus? Yes or no? Tell me. Cartesian.
Yes, sir.
So negative on the left-hand side of this origin. This is my origin pole. So if I measure any distance towards the right, any distance towards the right, note it down. Any distance towards the right from the pole, right from P. P is my origin. What it will be, positive or negative? This will be positive. Okay? The right will be positive sign. I will give positive value, positive sign. If there any distance is 5 supposing, then I will write +5 if it is on the right side. Okay? If it is on the right side, this values will be taken as plus, positive. If I say 5 centimeter right, then I will take +5 centimeters. Clear? What is the next thing? If any distance is towards the left, what is the sign then? Tell me what is the sign? Any distance to the left from P. P is my origin. What sign it will be used? The sign will be negative. Negative, how do we represent negative? Minus. So if I have any distance on this side, supposing, you know, in case of a concave mirror, object is always placed in front of the mirror. Tell me yes or no. If I use this, if there is a concave mirror, students, if I have a concave mirror, where is the object? This is my object. Yes or no? Tell me. AB is the object. Now this object is placed where? In front of the mirror. This is negative or positive? Tell me. Distance of the object will be negative or positive? If I'm moving this side, positive. If I'm moving this side, negative. So this distance, what will be this distance? This will be negative. For a concave mirror, if AB is the object, it is placed where? In front of the mirror. Placed in front of mirror. Then what will be this distance, student? This distance will be negative. It will be negative. Is it clear? Tell me yes or no. This distance will be negative. So distances which are measured to the right of the pole, positive. Distances measured to the left of the pole, negative. Note it down. Note it down. Object is always placed in front of the mirror, so that I'm measuring from pole, that will be negative always. Negative always. Did you note it down? Further, student, you see this is the image, this is the object. And if this is an axis, student, okay, this is my center of the axis, this is my x-axis, which I am calling as Cartesian. This side, this is my origin, this side is positive, this side is negative. Now, if an object is like this is above the axis, this is above the axis, yes or no? Tell me. This is above the axis. And height upward, this height, if this is the height h, then height upward is taken as positive. Height upward, like this, will be positive, student. If something is below, then what will happen? Height upward is positive, and height downward, height downward will be taken as negative, students. Note it down. Okay? Anything which is like this is my optical center, this is my x-axis, this is, so if the object is there in front of this mirror, as you see, this is height, this is positive, But if something is here, what happens? Then this is below the axis, downward axis. Then this will be taken as negative. Negative. Is it clear? Positive and negative. This is the sign convention which we always use. We will be giving the mirror formula and solve questions on that. First, you convince yourself that the direction of the incident light is this side. Why? Because the object is placed, this is my concave mirror, object is placed in front of the concave mirror. It's always on the left for a concave mirror. And the light is going in this direction. When we will move in this direction, positive. When we will move opposite to this direction, negative. Height above, anything which is above this axis, positive. If image is formed, this is my image. This image is formed below the x-axis, yes or no? This will be taken as negative. Is it clear? Tell me, are you sure what I said about the sign convention? Note it down. Very important questions are going to be solved on this. Note it down. Further, students, what we are saying. The object is always placed to the left of the mirror. Is it correct? Tell me yes or no. Are you placing object always towards the left of the mirror? Whether it is concave or convex? Yes or no? Tell me. This implies that light from the object falls on the mirror from the left hand side. Then what will be the distance of the object? Distance of the object, student, from pole, it will be then negative or positive? Tell me, it will be negative or positive? Because object is placed to the left. When you move to the left, what is it? It will always be negative sign. Yes or no? Clear? First point. Because the object is always placed to the left. This is my mirror. This is my mirror, student. The object is placed to the left. So if I will move like this from pole, then this value will be negative. Second, all distances parallel to the principal axis are measured from the pole of the mirror. Or where we make the measurement from the pole of the mirror. This is my pole of the mirror. So which are parallel to the principal axis. They will be measured from where? Pole. So every measurement will have to be done from this point. Pole, which I am showing. All distances measured to the right of the origin along axis are taken as positive. All those which are this side, they will be positive to the right of the origin. What is the origin? This is our origin pole. This is our origin here. So all distances towards this side will be positive, while those measured to the left of the origin, this is my left of the origin, they will be taken as negative. Is it clear? Third one, rule 3. This is the sign convention which will be used in the mirror formula, which I am going to give you. Fourth, distances measured perpendicular to and above the principal axis along the y-axis. What I told you, student, this is my origin, this is my plus x, this side is my minus x, and you have another axis, student, here. You have seen in maths, this is my plus y and minus y. So you have two axes. This is my x-axis, this is my y-axis. Is it clear? How do we write x and y? This is the negative. If I go below this, so this is my y, this is plus, this y is minus, and this plus, this is plus, and this x is minus. Is it clear, the sign convention? So anything, distances, whatever distance we will measure perpendicular to and above the principal axis, they will be taken as positive. All, whatever measurement you will do, for example, this measurement, this will be positive. This will be positive because it is perpendicular and above, it is above the principal axis. Above principal axis. Anything which is below the principal axis, what will I do? Distances measured perpendicular to and below the principal axis. This is below principal axis. It will be taken as negative. negative sign for this. Okay? Is it clear? Note down the sign convention. Now we are giving you mirror formula and magnification. Mirror formula and magnification is very important. There will be questions on that. This mirror formula is applicable for all spherical mirrors for any possible position of the object. In spherical mirror, the distance of the object from the pole is called the distance is called the u. So what we say, distance of object where you will measure it from the pole, from pole, which we have some p is equal to u. That is the distance of the object. And distance of the image, student, where you will measure it from the pole. Every measurement is done from the pole, which we said is our origin. From the pole, P is given the symbol V. This is my V. U, this is V. And the distance of the principal focus from the pole. Distance of principal focus from where? From pole. From pole P is written as F. And there is a relationship between these three quantities. What is the relationship, student? That is called the mirror formula. Note down relationship between object distance, image formed. We have already drawn the ray diagrams for convex and concave mirrors in the previous lectures. The mirror formula is, this is called the mirror formula. What is the mirror formula which we will be using, student? I am not deriving this. This is not required in our course. 1 by V plus 1 by U is equal to 1 by F. This is the mirror formula for spherical mirrors. For spherical mirrors. Note it down. Note it down, student. Mirror formula for spherical mirrors. What is V? Distance of the image from the pole, distance of the object from the pole. F is the focal length. Sign convention. Sign convention, we have already said sign. What is the sign of U, V, or F? That we have already discussed on the Cartesian sign convention. So sign convention based on what we have shown, Cartesian sign convention has been given to you. That will be used. That we have to follow. We have to follow what we have to follow, Cartesian sign convention. That must be followed. Next, we are coming, student, magnification. Student, what do you mean by magnification? Image, object is there in front of a mirror. It will form an image. The question is, what is the size of the image? It can be more, it can be less. The image formed can be enlarged or image can be smaller. So how do we know? How do we compare the size of the image and size of the object? This is compared by using a magnification produced by spherical. This gives the relative extent to which image of object is magnified with respect to object size. Relative. Comparison is always relative, that whether image is of the same size or the size of the image is smaller or larger than the size of the object. That formula here we are given. How do we find magnification? The ratio of height of the image to the height of the object. First formula, magnification. M, I am saying ratio of the height of image, which we are saying here H dash, divided by height of the object. That is my H. So this we are saying H dash by H. Supposing, student, that the image height H dash is 1.5 centimeter and object height is 1 centimeter. Then what will be the magnification? 1.5 by 1. In other words, what we are trying to say, the image is 1.5 times larger than the size of the object. Is it clear? So we have to know the height. But then again, there will be a sign involved. If image is formed below, then you know it becomes negative. If image is above the principal axis, it is taken as positive. So we have to be careful about the sign convention. Object is always placed upright. Object is always above the principal axis. But where is the image? Below. If it is below, it becomes negative. Magnification becomes negative. When magnification is negative, it means the image is inverted and below the principal axis. So it is a very good information. And there is another formula to find the magnification. We are talking of magnification of spherical mirrors. What I'm talking? Magnification of spherical mirrors. Spherical mirror, student. Another formula of magnification we are giving h dash by h is also equal to minus v by u. Now here we are using minus v by u, student. That's another formula. What is v? Distance of the image from the object divided by distance of the image from the pole. V is the distance of, this is negative sign here, distance of image where you measure from the pole. From pole divided by this negative sign I'm putting here, negative sign. Okay? So that there is no confusion. Divided by, students, distance of object from pole. We always measure distances from the pole. Sign convention will apply as per the rules told to you. Sign convention is always as per the rules which we have told. So the height of the object is taken as positive if object is placed above the principal axis. Okay? You know, sign conventions will apply. If object, you know, is above the principal axis, what will be the sign? Positive. Be positive. Okay? And object is, we are always putting the object above the principal axis. What about the image? Sign of image. Note it down. If image is above the principal axis, student, what will be the sign? What will be the sign? Positive.
So positive.
And if image is below the principal axis, image below principal axis, what will be the sign?
Negative.
Negative in the formula which I have given. Here there is no sign here, but signs here will be decided by this. This is always positive because it is above the principal axis. If image is above, positive. If image is below the principal axis, that will be inverted image, and always real image. Then it will become, h dash will become negative. Similarly, when I talk of the sign of u and v, the sign of u, if it is to the left of the pole, if object is always to the left of the pole, left of pole P, then what is the sign? Tell me, negative or positive? When something is left to the pole, is sign negative or positive x? Negative. And V for image, if image is formed to the right of the pole, if image is to the right of the pole, tell me what will be the sign? Positive or negative? Image can be formed left of the pole. then what will be the sign? Right means, pole right means positive. And images from left of the pole, then what is the sign? Minus x, negative. Is it clear? Note down the sign convention. That is where the confusion comes to the student, sign convention. Questions will be there and the whole confusion will be the sign convention. Student, who should be very careful of the sign conventions. That is where the problem comes with most of the students. When we will give you the sign convention, student, all the problem will be in the sign convention. So you note down, student, note down everything. This question will be there in the exam, very important. So you may note that the height of the object is taken as positive. Note that the height of object is taken to be positive as object is usually placed above the principal axis. So object height. Usually I am saying positive. Why? Because this is a principal axis. Object is always above the principal axis. It is above. This is my center. This is my minus x. This is my plus x. This is my minus x. And if I take it, this is my plus y and this is my minus y. So object is always above the principal axis. Therefore, object height will be always positive. But for images, if image is below the principal axis, student, this is my plus x, this is my minus x. If image is below, then what will be this, positive or negative? So this is the height of the image, This is the object height of the image. This type of images, you know, are real images. Real images are inverted and formed below the principal axis. So what will be the sign of the height of image? Negative. And if image is above, what type of image is that? If image is above the principal axis, plus x, minus x, above the principal axis, what type of image is this? It will be virtual and irregular. What will be the sign? Positive or negative? Sign for the height of the image, this will be positive. Is it clear? Sign convention. So when the sign is positive, if magnification comes plus 2.5, for example, I'm saying magnification is plus 2.5. When it will be plus 2.5, tell me what type of image is this then? What is the nature of the image, student? What is the nature of image? Sign is positive. Is it virtual or real? Positive means where is the image, above or below? Above the principal axis. Then what is the nature of the image? It must be virtual. Is it clear? The image will be virtual. And you can see it is plus 2 and it is enlarged. Size has become 2.5. If M is negative for the spherical mirrors, M is negative sign. Magnification, I am saying, is minus something, minus supposing 1.5. This sign is negative. What it means? Where is the image? Above the axis or below the axis? Height is negative. Height is negative means what? What type of image will be this? This will be a real image. Did you understand what I said, student? Very important. In the MCQ question, they will ask like that. Note down everything. Note down everything. Very, very important question, student. So here is a top question based on this. How will we solve it, student? Let us see. Question. A convex mirror used for rear view on an automobile has a radius of curvature, of 3 meters. Now, what is a convex mirror, student? This is our convex mirror. Right? I don't have to write it here. You know about it. This is a convex mirror. This is the reflecting surface of the mirror. What is the reflecting surface of the convex mirror? You've already seen it. We have drawn the diagrams for the convex mirror. And how do we draw the images? You have seen, student, the principal axis. We have shown this is our principal axis. And you have a pole. Okay? And you will have the focus behind. And at the double, you have center of curvature. Center of curvature. A convex mirror is used for rear view on automobile, has a radius of curvature. What is radius of curvature, student? This distance from this distance, PC is equal to R. How much is that? 3 meters. Then this, what will be the focal length? PF or F. You know what will be F then? 3 by 2, 1.5 meter. 1.5 meter. Is it clear? Now, what he's saying? What he's saying, if a bus is located at 5 meters from the mirror, the bus is located, student, this is your 3 meter. If I'm drawing 3 meter, this is 1.5. So bus is located. If a bus is located, student, somewhere here, 5 meter. 5 meters. Object is always placed in front of the mirror, that we know. If an object is placed, if located at 5 meters, students, okay, from this mirror, object is at a 5 meter from this mirror. A convex mirror is used as a radius of curvature. If bus is located 5 meters from this mirror, find the position, nature, and size of the image. You have to find the position, nature, and size of the image, student. Question. So tell me, what will be the value of U, students? What is U? Distance of the U is the distance of object from the pole. This is a bus here. This is a bus is here 5 meters. So what is the value of U, student? What is it given? 5 meters. It will be -5 or +5. Tell me. Use the sign convention.
So -5.
It is, this side is positive from the pole. This is my center. And this side is taken as negative. Okay? So this U will be -5 meters. Next, what it says, the radius of curvature R is towards the right or towards the left? Tell me. This R is the convex, in a convex mirror, where is the image formed? It is not formed in front of the mirror. It is divergent mirror. It is formed, the F and C are behind the mirror in this direction. So what will be R, positive or negative? Tell me.
So positive.
+3 meters. And what will be the value of F? 3 by 2 plus 1.5 meters. Is it clear? So what do you want to find out, students? Then what is the mirror formula? What is the mirror formula, first of all? 1 by V plus 1 by U is equal to 1 by F. So by using this formula, what will we get, student? Find value of V. How will we find V? Do we know the position of the image from this mirror? Find position of the image. V is the position of the image, student. We have to find V. So 1 by V is equal to 1 by F minus 1 by U. What is the value of F? 1.5 plus. And what is the value of U? Tell me. Minus 5. So what will the answer come, student? 1 by 1.5 minus will become plus 1 by 5. So what will be the LCM of this? 7.5. 1.5 means 5 and this will be 1.5. What will be the answer? What will the answer come, student? 6.50 by 7.50. Okay? That is our V. 1 by V. So 1 by V is equal to, student, how much? What is the answer coming? What is 1 by V? 6.5. 6.5 by 7.5, or V will be equal to 7.5 by 6.5. If you divide the two, what answer you will get? But it will be 75 by 65. 75 by 65, student. 75 by 65. What answer will we get, student? It will be 1.15 meter. This is coming positive. So V is positive, student. If V is positive, tell me the image is above the principal axis or below the principal axis? Tell me.
Sir, above the principal axis.
So that means, student, the image is above principal axis. Image is above the principal axis. So what type of image will be this? If it is above the, it will be, tell me, will it be virtual or it will be real? If image is above, it is erect, then is it virtual or real? That means image will be virtual. Clear? Note down everything because this is very important. He has asked what is the nature of the image. The image is virtual because it is above the principal axis. If it is inverted, then it will be below the principal axis. Then it will become real. And we already know rear view mirrors. Bar I am talking about convex mirror. This is very important. They form virtual erect images and you can see the complete distance. And now what is the formula for the magnification, student? What is the magnification? Magnification, M is height of the image divided by height of the object. Height of the image divided by the height, which is also equal to minus V by U. What is the value of V? What is the value of V?
So 1.15 meter.
Minus 1.15 meter. And what is the value of U? Minus 5 meter. Then minus and minus will become plus. Then what answer you are getting? 1.15 divided by 5. What will be the answer? 1.15 by 5. You divided, you will get 0.23. So the image is 0.23 means is the size of image is larger or smaller than, tell me. Is the image bigger?
So smaller.
It is diminished. Very important. What you are getting? Diminished image. How much diminished? You have seen 0.23. The size is 0.23. Then how you draw the ray diagram, student? Now you already know about it. The rays which are parallel, they will appear to. There is a divergent. It is a divergent. It is diverging. You can see that divergent. And they appear to diverge from the focus. And other one, students, will pass through the center of curvature. And that is the point where they intersect, student. That is where the image is formed. So what you get, this is the size of the image. The bus has become smaller in size. If this is AB, what you are getting? A dash, B dash. So what is the nature of the image? Virtual, erect, diminished. And what is the, where it is formed? What is the value of V? Where was V? 1.15 meter. So it is at 1.15 meter, whereas F is 1.5 meter. So that what we are getting, distance of the V is how much? Plus, let me put it here, V is equal to plus 1.15 meter. This is between, what is the focal length? How much is this distance? 1.5. This is less than 1.5. So between where? P and F. Note down everything between P and F. Virtual, erect, diminished, V plus point between P and F. Between P and F. That is where we have shown it here, students. You can see, and magnification, it is 0.23 times the size of the object. 0.23 times. If its object is 1, then it is 0.23. So it is diminished almost by 75%. Is it clear? Tell me, everything clear? This is an important question which has been solved. I hope everything is clear to you, students. Right? All right, students, this is important. This ends up here. We will continue in the next class more about it, solve more and more questions, and you will get recorded videos as well as all questions will be solved. And keep subscribing our channel and forwarding it to your friends so that the next exam which is coming, we can get full marks, and a lot of question answer sessions will be there based on the latest syllabus and the course which is declared by the Cbse for your exams coming in November. All right, then I will meet you in the next class. Bye-bye.
Thank you, sir.
Okay.